In this clip, we're going to simplify each rational expression and, if applicable, write the restricted domain on the simplified expression. All right, so we're continuing this idea of canceling out factors of 1, but in order to do that, we need to make sure everything is fully factored. In this first example, there's no factoring to be done. We have 7a cubed over 21a, right? So in an example like this, take a look at the numbers there. We have 7 over 21. That reduces to 1 over 3, right? And the a values there, we have 1 downstairs and 3 upstairs. Okay, so the 1 downstairs will cancel, and then we'll be left with 2 of them upstairs. Okay, so what do we have there? We have a squared divided by 3, right, is what that ends up being. And I would also say that a cannot be 0, right? Because a was in the denominator originally. If we looked at that original expression, we would have said, well, a can't be 0. And so that has to apply for our final simplification as well. So a can't be 0. All right, let's go across here to 6a plus 30 over a plus 5. Okay, so in the numerator, I see that I can factor out a 6, right? So I have 6 times the quantity a plus 5, right? And in the denominator, I have a plus 5, right, which is fully factored. And I can cancel those out, right? So that gives 6, right, as a final answer. But what do I also have to say? A can't be -5, can it, right? Because in the original expression, you would have said, well, if a is -5, that makes the denominator 0. So we also have to list that restriction. Okay. All right, so down below here, we have -6x plus 12 divided by 5x minus 10. Okay, so in the numerator, I'm going to factor out a -6. So I have -6 times the quantity x minus 2, right? So so in the numerator, I'm factoring a -6 out there. And then in the denominator, I can factor out 5, right? So I have 5 times the quantity x minus 2, right? If I factor out 5 from 10. Okay, so now I have this factor of 1 that can go away, right? But in doing so, I have to list the domain restriction, right? So I'm left with -6/5, but I have to say that x can't be 2, because if x was 2 in the original expression, the expression would have been 0. Okay, so we have to maintain that restriction all the way through. Okay, now this last one, here, I'll section this off here a bit. We have 7 minus x over 3x minus 21. Now, in the numerator, I don't see, at least right off the bat, I don't see any factoring that needs to be done there. In the denominator, I see that I can pull a 3 out, right? So I have 3 times the quantity x minus 7. So I notice in the numerator I have 7 minus x, and in the denominator I have x minus 7. So close, but not the same thing, right? Okay, so if you have a situation like that where you have some a minus b and in the numerator and a b minus a in the denominator, you can actually get those to be the same factor by factoring a negative out from one of them. So in the numerator, I'm just going to factor out a -1. Okay, so do you see what I did there? I essentially took out a -1 from both 7 and -x. So if I distribute that negative back through, right, I've negative times the quantity negative plus x, but if I distributed the negative back through, I'd have 7 minus x, right? Okay, fun trick. Now what did that do, right? I'm going to leave the denominator alone, and I'm going to rewrite those terms. -7 plus x is the same thing as x minus 7, right? Yeah. Okay, so see how that works, right? That's a great fun trick to get you to get things simplified further, right? So I can cancel out the x minus 7, and I'm left with -1/3, and I want to say that x can't be 7, right? In the original expression, if you let x be 7, you'd have 3 times 7 minus 21, which would be 0, right? So it can't be 7 in the final simplified version either.